Hello, friends. Welcome to episode 7 of Kermit GNC. So, today we will do some analysis. What we will cover in today's episode is I will show you how to use the signal editor blocks in order to send pulses and doublets for analysis purpose. Usually, whenever they do flight dynamics models like this, they they run smaller analysis every now and then to verify that the model is working as expected, because you definitely don't want to build on top of a broken foundation, right? So if you have, it's basic garbage in, garbage out. uh, in order to avoid that, we need to do some crucial analysis, and here this is a good point. Since we have a solid foundation built up, we can do some mode analysis. Now, what that means is, so an airplane basically has longitudinal motion that is, along the longitudinal axis. So basically that has to do with pitch mainly. And then it also has lateral directional motion, which is basically roll, yaw, and then roll, yaw coupled. So, for the longitudinal motion, how do you verify that your airplane is behaving as expected along the longitudinal dynamics? You do a short period, you look for a short period mode and a phugoid mode. A short period mode, as the name suggests, that is characterized by fast oscillations and rapid oscillations for several cycles, and then heavy damping. So short period because it shows up for a short time as well, and then it vanishes quickly. Phugoid, on the other hand, is, of course, oscillations linger, and it's weak oscillations, not as heavily damped as short period motion would be. And phugoid mode helps you to see your energy exchange, basically potential energy converting to kinetic energy in an airplane. So if you see your phugoid mode on the analysis, you know your airplane is doing a good exchange of that energy. Short period, on the other hand, think of that like the wing and the tail of the airplane are arguing about the angle of attack. So that's a good way to look at it. On the lateral directional modes, we will try to look for, roll subsidence, Dutch roll, and spiral mode. Now, roll subsidence, think of that as the airplane, whether it is able to resist roll rate and settle down naturally. So, roll subsidence or roll damping, right? It's a sharp roll rate response followed by exponential decay. Dutch roll, that can be thought of as whether an airplane feels smooth or wobbly in yaw. So, rudder response, you give some rudder pulse, and I will talk about the difference between doublet and pulse. You give some rudder pulse, and that that affects beta, so you get oscillatory beta that gives you oscillatory yaw response, and then eventual damping. So hence the name Dutch roll. So you give rudder pulse. Remember, even if the name says Dutch roll, we are not going to give any aileron input. That will be neutral. We will only give rudder pulse. Then spiral mode. Spiral mode is when an airplane is banked, gravity wants to pull the aircraft into a descending turn. And those of you who are pilots, you would very well know what I'm talking about. At the same time, when gravity puts the airplane into a descending turn, the dihedral effect and directional stability try to level the aircraft. And the winner, whether it is gravity or it is the stability derivatives, determines the spiral mode. So that's a good way to think of it. Now, of course, you do not want the gravity to take over. That would be worst case, which is why we do these analysis to make sure that that's not the case. When it comes to spiral mode, you have three different spirals that you can capture with the analysis we will do today: stable spiral, natural spiral, and unstable spiral. Um, Natural or neutral spiral for that middle one. So as the name suggests, stable spiral means bank angle slowly decays to zero and aircraft levels itself, which is desirable, right? Neutral spiral means, again, bank stays the same or bank angle stays the same. An unstable spiral is when bank angle slowly grows. And you may want some unstable spiral, but eventually you want it to stabilize, whether it is automatic stabilization through the algorithm or be it with pilot input, right? So let's dive into it. And towards the end, I will show you, well, actually, as we build these, I will show you a cool feature that Simulink provides, which has to do with annotations, how you can separately color code every annotation block. I will show what I'm talking about when I get there. In the end, I will point out how you can use the clock feature. We will talk more about it when we do that again. Now let's get started. So, this is where we stopped last time in the previous episode. So if you haven't gotten a chance to check that out, the link is below in the description. And if you are liking my videos so far and you see that being useful, don't forget to like, subscribe, and comment. That would definitely give me essential feedback going forward. Alrighty. So, what we will do is let us start with the longitudinal modes. For that, I will show you how you can use signal editor blocks. So, we will put that here. Now, double click, write down signal editor, which is this one here. So I get signal editor. I will show you how you can configure this block in a little bit. Let me get two more copies and I'm going to use them for yaw and for aileron deflection and rudder deflection too. So let's make some room for these. Now that's where I will show you how you can separate things. Look, you see this icon on the side here, the icon that says area. You can click on that and build a custom area for yourself like that. Let's see. What that will do is if you hover over it, you see the yellow bars or the gray bars. You right click on the gray bar and this icon here lets you to choose the color for that. Didn't work out. Let's try one more time. Okay, I need to select it. That's the preview. There we go. That's what I'm talking about, doing color-coded annotations. And this is a standard practice to keep things distinct, especially when you have your model grows. You want that, right? Let's get another one for rudder. And I'm going to space these out a little, but for now, that should be enough. Okay, and I'm going to get another one for the elevator. Like that. It will not be a bad idea to space these out. What these blocks do is you can just use those blocks now to move things around. Do you see that? It's that handy. So let me see. Okay, looks like this one did not get captured. I'm gonna color code this as well. Let's choose a color for that. That would do. Okay, let's try that. All right. Once you color code it, it starts to identify the whole thing. Up until then, unless you have the things properly inside of the block, it doesn't recognize them, as you can see. But this should be good for us. All right, that way I know which one is which. Super convenient, isn't it? All righty, so with that, let's configure the signal editor block. So double click on one of them and you see this icon, the editor icon here. You click on that, which will give you a dialog box like this. And this is where I'm going to put my signal I want to give. Now, this time I will give a doublet. A doublet is you doing a nose up. So you start from neutral, go nose up, back to neutral, nose down, back to neutral. That is a doublet. So basically you are making the nose go full travel for a few seconds, and that needs to be done quickly, which is why I am using signal editor block instead of the slider, because the slider you may not be able to do that quick response by just playing with the slider. So it's a standard practice in the industry that you use a signal editor block to give doublets like that. So for the elevator, I will give a doublet. Let me define my doublet. So on this signal editor dialog box here, on the left side, you have a way to name the thing. So it's called a scenario, and inside of that, you get a signal. So the scenario, let's make it elevator. So if you don't label it properly, the problem is every block will have a thing called scenario and signal. So you may not know which one is which, or the Simulink software may not know which one is which. And usually that throws errors at you later. So signal, and then I will call this my del elevator in degrees. Sure, why not, right? All right, with this on the right hand side here, you get your spreadsheet, if you want to call it, your time and data sheet. And check this out, how I am defining my doublet. So okay, and then these blocks kind of jump as you change the numbers. So give it a try, play with that. Once you play with it, you will get a feel of how they function, and you would be able to navigate your way from that. It's not crazy magic. Okay, and that will be 7.01, 0, and I need one more that will be 20 and 0. Now, as you notice, I have defined my doublet. I don't see this properly on the screen. So here is your handy dandy fit to view icon. Click on that and you can see. So I am going to command my airplane to go neutral for the first 5 seconds and then jump up to a positive elevator deflection, that is up to 10, which would be for 1 second, then jump straight back to -10, which would be for another 1 second, and then come back to neutral for the rest of it. And this complete maneuver is going to take 20 seconds, right? So once you have it all defined like that, you go to this signal editor tab, click on that and save. Once you do that, it will let you save it, and let's give a well-defined name to save it. I will say del E, why not? Okay. And once it is saved, you can exit out of this screen. You make sure that you have all the things right. So that I saved it at desktop. I see that elevator del E. Okay, all good. Let's hit OK. Now, since I will be using my signal editor and not the slider, I want to turn off or comment out my slider block so it does not interfere. So if you just hover over these 3 dots, you see this comment out option. You may have seen that option pop up several times in previous videos, but I didn't direct you what that is about. So that's comment out. If you click on it, it's going to comment out that block so it does not interfere. Same thing for this constant, because this constant, as you know, is connected to that slider. Now what I will do is I'm going to remove this link and use the link from the signal editor. You will know why I am still keeping the slider. It does come in handy. I will show you later why. This one, let me turn this off for now. And let me turn this off for now. I am not going to use that for my doublet maneuver or for my longitudinal mode analysis. So it's good to turn those off. I will also make sure that my aileron is neutral, pretty close. That would do. And my rudder and aileron are both neutral. So that's how I want them. On this right-hand side, let's get a big scope. With the scope, what I will do, I'm gonna need couple of signals to monitor at the same time. So what I will do is I'm going to get Euler angles. I need that. These are the standard things you need whenever you are doing your doublet maneuver and longitudinal mode analysis. I will need my alpha. So let's use a from block and get alpha. And you can directly drag the wire to the scope and it will adjust. I need my velocity, so I will use another from block. Let's get the V safe, and that can go there. Okay, and I need the altitude, and if you see, Earth frame altitude is this XE output here, and the Z element will be my altitude. So I need that. So let me come to the scope. Just click on one of the edges. That will give you a link, and the arrow, click on the arrow and drag while holding the mouse button. So that's how I define my scope. Let me double click on the scope. And I'm going to do a few changes to the scope. So click on scope. You see the display grid. You can actually do 4 different grids to see four outputs at one time. I will also get my legend. I need that. And let me click on the settings. What you can do, which is neat, is display 1. Your display 1 is Euler angles. So I can call that my phi, theta, psi. So that gives you the labels. If you notice, you see phi, theta, psi appear. Display 2 will be my altitude. So let me call that to be altitude. Display 3 is speed. And display 4 is alpha. Okay, all those 4 are done. Cancel. Make this bigger so we can capture everything nice and clean. One last thing before I run this is the stop time here. The stop time here, since my doublet is 20 seconds, let me keep a stop time of 100 and see how that looks. If I need more, I'll do more. So it may be a good idea to have your scope in front of you like that and then run from the scope. You know, you can run from the ribbon over here or from the scope. So I will do from the scope. All right, so we are getting some response and let's make them fit to screen. And what I'll do is I'll just keep the relevant things, meaning this is a longitudinal mode analysis. I want to look only at my theta. So let me turn off phi and psi and adjust one more time. I want to look for the altitude. It will be just the orange one, the Z. And for speed and alpha, I have everything neat. Let's make this bigger. Okay. So looks like with the 100 seconds, it may not be sufficient. So why don't we make this a 500 seconds and run it that way? Okay. And let's do one more run. Oh, wow. Beautiful. This is like textbook level. So let's talk about this. So you see this short period mode here between 0 and 50-ish seconds. This little guy, this is your short period mode. You can also see the short period mode pop up on your alpha plot and some of it on the speed as well. So That is characterized by heavy damping, faster rapid oscillations. So that's that. This one here is your phugoid. Phugoid is more lazy waves. That's how I think of them, lazy oscillations. That's the best way to remember phugoid. Now, now another thing you want to check before you say that this is phugoid on the theta plot is you want to check your altitude and speed plots. So basically, if altitude goes up, speed should come down. If altitude comes down, speed should go up. They gotta work inversely. And if that is true, then what you capture here on the theta plot is actually your phugoid mode. Sometimes you may see this wavy oscillation, phugoid characteristics, but you will not see expected behavior for altitude and speed plot. That will not be phugoid, right? So, and you can see while you are doing phugoid, alpha stays pretty constant. So that is textbook level marking of your longitudinal mode. Beautiful, isn't it? Okay, since we have captured that, let's move on. Next, I will show you how to do your lateral directional mode analysis. So let's start with roll subsidence. For the roll subsidence, I am going to keep my elevator neutral. So let me remove this wire now, and I will comment out this one, and I'm gonna uncomment my sliders. My sliders help me a lot in keeping the 0 mark easy. So let me see. Yeah, pretty close to 0. Let me connect this back again. Do you see why I kept the slider? Easy, right? Because just to keep 0, I really don't want to edit anything on my signal generator, and it may be a good idea to keep the signal generator, the defined signal open for, showcasing purposes later. All right, let's give aileron pulse. Now, why is this called a pulse and not a doublet? Reason being, doublet is you doing the entire motion, like nose up and nose down at the same time. However, a pulse is only unidirectional. So you just do it either nose up or nose down, only one-sided. Hence a pulse. I do not need a doublet to capture the lateral directional modes, so a pulse would be enough. Okay, I'm going to repeat the same process. This should be familiar to you. Let's call this aileron, and the signal, let's call the signal to be del A in degrees. Perfect. Let's define it. So we can say 0, 2.01, and that can be for 5 seconds, and then 2.5, that will stay at 5. Need 2 more, and 2.51 will be back at 0, and 30 back at 0. Okay, let's fit to screen. And this is my pulse, and you can see it's only unidirectional. So I'm going to give a positive aileron deflection for a half of a second, and then bring it back to 0. Okay, I am happy with it. Let me click on the signal editor, save this. Let's save it as del A. And then once we are good with that, let's do, okay, alrighty, let's do cancel. I have aileron selected. All right, that looks good. Let's connect it. So that can be commented out, and this is at 0. This is the one I want. So remove that connection, connect this, comment out the rest. Okay, now for the aileron deflection, for your roll subsidence, you want to really look at P. So you don't really need to do any of these. If you just look at your P plot, you should be able to capture it. Okay, now for that, why don't we set the time? Since our entire pulse is 30 seconds, I can just set this time to be 30. I would not need all 500 this time. All right, and now here is the scope. And this is my P, Q, R. And I want to really look at P. So let me turn P on and turn off all the rest of them. Okay, now running that. All right, let's see if we can. Okay, looks like something is not happy. Let's see, I don't see any error messages. So hopefully I chose the right scope. Let's do this. Let's cancel the scope and then open the scope one more time from here. And before that, I will make sure all my other things are turned off. Okay. All right, got my scope. Let's make sure everything else is nice. So this is at 0. This is about 0. Only one signal editor is open and it's connected to that. Everything else is commented out. All right, let's try it one more time. Okay, now if I have turned all the 3 of them off. Let me get my P. There we go, that's better. So this is your classic role subsidence behavior. As you notice, this I gave a little pulse, aileron pulse, and I do see my roll rate response. It responded to my pulse momentarily and then it got dampened back to 0. And that means my roll damping is actually working. My airplane is not going to keep on rolling in an unstable manner and put me in danger. So this is a critical check. And all of these mode analysis checks are critical at this point. So that's success. Let's also do, I'm gonna go off the order. I will do spiral mode as I am on the aileron anyway. So how the spiral mode works is, let me double click on my signal editor and I'm going to edit the pulse I gave. So what I will do different is I am going to, let me see, I'm gonna make this bigger first. So let's keep that for actually about a minute like that. And then let's make that. Okay. And that. The unique characteristic to capture a spiral mode is you want to have this thing run for a long time. So your pulse must be like a little longer like that. Okay, saving that again. All right, now everything is good. Let's run this again. Now to capture a spiral mode, you want to look at your phi plot. And if you recall, phi is inside the Euler angles. So if you want, you can capture, like look at that with this big scope, or you can just open Euler angles scope, right? Now, before we do that, let's change our stop time. Let's make it 120 seconds to match with the pulse I am giving. And here is my Euler angles scope. Now, since I am monitoring my lateral directional spiral mode, which has to do with aileron pulse, let me keep my, there we go, let me keep my phi on and theta and psi can go off. Okay, let's run this. All right, here is that. I'm gonna fit to screen. Look at that beauty. So the way you want to identify your spiral mode is for a stable spiral, like we were talking in the beginning of this video. It should respond to your aileron pulse. And then, so the roll angle should respond to your aileron pulse and eventually should come back down to 0. And this one is supposed to be slow, like very slow. And the fact that it's taking about 120 seconds to come back down to 0, and still it may take some more seconds, right? There's still a steady state error there, which is typical. So if you see something like this, you know it is a stable spiral. And that means, again, your airplane is able to cancel the bank and bring everything back to level flight, which means it's not going to kill you. All right. Now, last but not the least, let us configure everything for analyzing our Dutch roll. All right. So for the Dutch roll, I would need rudder pulse. So let me turn this off, bring these back on. I'm sure there is a better way to do these, and we will figure that out along the way, right? We are planning to play with this for the long haul, so sooner or later we'll figure it out. So let me turn this wire off and then connect it. This is at 0 neutral, this is 0 neutral. Let me get this on and turn or comment these blocks. All right, there goes that. All right, let's double click on this and let us design a pulse, a rudder pulse, so to speak. So my signal is gonna be rudder, and then, sorry, my scenario is rudder and signal is del R in degrees. Nice. All right, let's define the rudder pulse here on the right hand side. So this will be 2. Let's add some more. Rudder pulse will look similar to the aileron pulse we gave for roll subsidence, not for a long time, for a short duration, really. And that would be enough to capture what we want to capture. All right, let's do that for 60 seconds. That's how my rudder pulse is gonna hit. Okay, let us save that. I'm gonna call it del R. And all right, so to capture the rudder pulse, you wanna look at your beta and R. So what I will do is I am going to remove some of these and I will get beta instead of alpha. And my R can come from that. So all these connections can be lost. There we go. Now that also means I'm going to double click and reconfigure my scopes. So here display grid can only show 2 this time, and settings. Let's do that again. All right, let's get the settings. Okay. Over here, my display 1 is actually, this time it would be PQR. And to remind you, we are only going to look at R. So I will turn the other guys off. And display 2 is beta. Isn't that so handy? That way you can look at multiple things at one time. All right, before we run this for the last run, let's change this to a 60. Since I'm already here, I'll show you a feature. Let me finish off with the analysis. Okay, let's give that a run. All right, I'm only going to look at R. So here is my R, everything else turned off. All right, so now that you see beta R. Now, for a successful Dutch roll, your beta should spike up and then dampen down, and your R should also follow the same trend, spike up and dampen down. And if you look, that is the case for both of these, right? In about, what is this, 60? So in about 10 seconds, you can see the things responding as they should be. So that's a textbook level Dutch roll. Now, what happened there? Again, we are trying to confirm whether an airplane feels smooth or wobbly in yaw, meaning when you yaw an airplane, is it able to eventually dampen that yaw angle and bring you back to level flight, right? And that too smoothly. And this does look like it is doing the thing. So that is that. I will show you one last thing is, let's say if you ever try to run this not through a signal editor, but through the slider. I don't know why you would do that, but let's say if you want to just play with it, not for mode analysis, but for the sake of the model. So let me show you how that would work out. So if you double click, it should come back to life. Okay. I'm going to show you with a rudder example. Okay, let's say I open the scope and I want to have the scope side by side with the drawing. Let's hit a space bar there. Now let's say I want to run this for infinite time, and I want to do the slider movement as the model is running. Now check this out. If I hit run, do you see how I can do the slider? Let me try. Okay, I did some. Now I'm going to stop it. Now this. So by the time I try to do anything, I'm already past 6,000 seconds already. And this one goes so fast. It's hard for me to even do my changes within like 5 seconds or 10 seconds, right? Hopefully this will be a good example to show you the importance of having signal editor block to send pulses and doublets. But what you can do is, if you hover over this run, now you see the drop down. If you click on the drop down, there is the simulation pacing. The simulation pacing helps a lot. If you enable pacing to slow down simulation and keep this at 1, that means your simulation time is going to match as if it is wall clock second, like wall clock time. Now check what happens if I run this again. Now it is slower, so you may be able to do your things and look at them at the same time rather than the response speeding over you. So now, perfect, like that. So here is, and you can turn on and turn off the simulation time. Now, if you want analysis to go faster, you don't want it to go slower, you can always come back and turn it off. That's a pretty handy feature. Hopefully it will be useful to you. Keep playing with these things, keep hitting those troubled spots, and if you find any, do comment below. I would love to know your experience. Hopefully this is useful. See you next time.